we're looking at these problems here, and I'm giving you a series of points, K, M, S, and T, and we're going to have to determine whether or not the line KM is going to be parallel, perpendicular, or neither to line ST. So in order to answer that question, I have to use what? Midpoint, distance, or slope? Slope, because we know that slope tells us whether lines are parallel or perpendicular. So how many slopes am I going to have to find to answer question 1? Just 2. Very good. So I'm going to find the slope of KM and then the slope of ST and compare them. So let's find the slope of line KM first, and then we'll find the slope of ST. So when I have it written in this format, what do I do to find it? Raise your hand. Tell me who knows how to answer this question. Zara? Go ahead. Oh, I thought you raised your hand. You didn't raise your hand. Okay. Okay, good. So let's start with Km. So if I'm going to say y2 minus y1, it's going to be 4 minus what? So 4 minus a negative 2. Are we okay with me just making it a plus at this point? Okay. And then Jessica, go ahead and finish it off for us. Perfect. So I'm going to have 6 over 10, which does reduce, and you should always reduce your slopes so we can really definitely see whether they're perpendicular, parallel, or neither. And so what does 6/10 reduce to? 3/5. Good. All righty. So now we're going to go ahead and look at ST. And again, we're using the same formula. So Courtney, can you read that and tell me what numbers would go into there? We got to do the y's. So what are the y coordinates? Because y's go on the top, right? That's actually a negative 4. So negative 4 minus 6. And then what would go on the bottom? Can you see that from back there? 3 minus a negative 3, or 3 plus 3, right? So I have negative 10 over 6, which again reduces to negative 5/3. And so I'm going to be comparing those two numbers. And all you have to do at this point is look, and are they exactly the same? No. So they're not parallel. We can rule that out. Are they opposite reciprocals? So what does that mean the two lines are going to be? Perpendicular. Very good. So these are going to be perpendicular. Okay, very good. How about number 2? What did you get for the slope? What did you get for the slope for Km here? Okay. Okay. And did you notice he went in a different order? Did you notice he went from here to here? Is that okay? Perfectly okay as long as you're consistent. If you're going to start with K and go to M, then you need to do that in both the numerator and the denominator. Okay? And so I got what? Negative 4 over negative 6, or 2/3? Is that what you got? Yeah. Okay. And then how about just tell me what the slope you got for ST was? 9 over negative 6, which gives us a negative 3 over 2. Okay. What? Negative 3 over 2. It doesn't matter where the negative goes, top, bottom, or out in front, right? Okay. All right. So what are these now? They also happen to be perpendicular. Now that's a coincidence, okay? They're not always going to be perpendicular, right? What would a neither look like? Right, so like 1/3 and 2/5. Those would be neither parallel or perpendicular, right? So they're not exactly the same. If they're exactly the same, they're parallel. And then these are two cases of what we would say would be perpendicular lines. Good job. All right, the last one down here in number 3, I wanted you to graph the line. And we kind of did this one at the end of class last time, where it's going to be perpendicular to line EK. And I have those 2 points, but it's going to contain this other point. So we need to graph all these points first. So let's graph negative 2, 4. So here's going to be point E. We're going to graph 2, negative 2. And that's going to be point K. And then we're going to draw the line that contains those. I'm just going to draw it with a segment tool, but it really is a line. That's okay. Make sure it's exact. There we go. All right, so I have E and K on there. And now I'm going to graph point -3, 0. And this is kind of like one of those SOL questions, right? Where it's going to say plot the other point that would make line Z whatever, we'll call it ZA, ZA, I don't care. We're going to plot another point that's going to make a perpendicular line. And so you can imagine on your SOL taking that little pointer tool and just clicking somewhere on the grid, because that's what's going to happen. So where would I graph it? What would I do to answer the question first before I even start thinking about a point? Find the slope of which line? EK. Good idea. So let's go ahead, and it's okay, and some of you said it on your homework, you just counted to find the slope. That's perfectly okay, as long as you tell me what the slope is, okay? So to go from E to K, I'm going to go up 1, 2, 3, 4, 5, 6, left 1, 2, 3, 4. So 6 over 4. There's a mistake there. What is it? I'm sorry? It's not reduced. Okay, so let's reduce it. And what do we get? 3/2. There's still a mistake. What is it? Someone said it? Negative, right? Because the line's negative, my slope's not looking negative right now. Doesn't matter where I put the negative. Top, bottom, or out in front, I don't really care. I just know that it's -3 over 2. So what slope do I want it to be? So this is the slope of EK. I want the slope of, we'll call it ZA, whatever. So we're going to graph the point. Okay? So let's graph point A. Where is A going to go? How do I get point A? Where do I put it on my graph? Any ideas? Do I want to go down 3, right 2? No. I want to do what? Okay, so what slope do I want ZA to have? Positive 2/3. Would you agree? So from point Z, what am I going to do? Up to right 3. Very good. So up to 1, 2, 3. And so this point here, which is the point, looks to me like 0, 2. Would you agree? That looks to me like it's going to be a perpendicular line. Hang on, that doesn't look perpendicular. That does not look perpendicular. Let's double check ourselves. Are we sure we did that right? Hang on. Let's make sure. Let's count. Let me count again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, that's right. And then we want it to be positive 2 over 3. 1, 2, 1, 2. That's right. Does look weird though, doesn't it? What's wrong with it? It does look weird. I don't like the way it's looking. Let me step back. Did I do something wrong? Is it the same thing algebraically? It's just the way, maybe it's just the graph is skewed. Doesn't the graph look like it's kind of squished in? So maybe when I just copied the graph, it just kind of made it look squished into you. But that is always something we should check, don't you think? We should always double check that it looks perpendicular. So I agree. I think maybe that graph just kind of, the way I copied it into the file, got all kind of skewed and weird. But that is the right answer. All right, let's go ahead and check your answers to your homework. I'm going to pause the recording for a second, double check, and we'll go over whichever ones you want. We should talk about how to write the equation in slope-intercept form. So let's look at that homework problem. So in 24, this is what you're given. Y minus 7x is equal to 6, and y plus 7x is equal to 8. They're not in slope-intercept form right now because, why? That's what I just said. It's not in slope-intercept form because it's not in slope-intercept form. Well, all right then. Yeah, I agree. It's not in the form y equals mx plus b. And you guys know what that is. And you know that the number with the x is the slope, right? So that's what we'll end up comparing. But we have to solve them both for y first. So to solve the first one for y, what do I need to do to both sides? Baruch, I need you to put your head up and you get a pencil out, okay? Same with you, Shervin. What do I need to do to the first equation? Dina? And to do that, I would do what? Which is what? Perfect. So I'm going to add 7x to both sides. Can I add 7x and 6? No. All right. So these are going to cancel. I'm just going to rewrite this one down here. And so I'm going to write the 7x first, just so it looks exactly like y equals mx plus b. Okay? How about the second one? What do I need to do to solve for y in this case, Esteban? What would I do? Okay, perfect. Just to get it moved, so y is by itself. And again, I'll rewrite this one down here. So I have negative 7x plus 8. What do you think I'm going to do at this point? Once I have them solved. So they're both solved. I'm looking at these two equations here. And I'm just trying to decide if they're parallel. What would I look at? Perfect. And I'm going to be looking at 7 in this case and negative 7 in this case. Are they parallel? No. Are they perpendicular? No. They're neither. This would be a case where they're neither. They're just going to intersect, not in a 90-degree angle. Okay? So not perpendicular. This would have to be like negative 1/7 for them to be perpendicular, right? So they're not parallel, they're not perpendicular, they're just neither. Jessica, does that help you? Yeah, it's just a matter of just putting it in the right form and comparing slopes. And I guess the last one, 36, is the same way. Except for that's the one I graded for home extra credit, and that's the one, I think those end up being perpendicular, don't they? So 36, I believe, negative 1 and 1 was that same case we were just talking about in 18. So they are perpendicular. Okay? Good? All right. If you would please, go ahead and take out your slope note, your note card here. Okay, one thing. 30? I don't know. I think they were parallel. Okay. All right, if you would, your slope note card. Slope. You should be on the right-hand column of your flip chart at this point, right? Okay. I'm going to turn one of these lights on just so we can see a little bit better. This should be on the top right. Okay, you should have 3 cards over there that are blank. We're going to fill all 3 in today. We're going to start with the slope. The middle one is going to be parallel versus perpendicular. Hopefully you fit all that on your card. And then the last one is going to be equations of lines. All right, so we should have three note cards on the right-hand side, right? Remember, if you're not taping, you want to write them at the very, very bottom because otherwise they won't show. Because like right here, if you watch me, if you do this, you can't tell what they say. Does that make sense? Okay. So that's why I have it written at the bottom there. All right, so with slope, we're going to go ahead and write a couple of things. I want you to draw 4 pictures on the front that deal with positive, negative, 0, and no slope. So on the front side of your slope note card, I literally want you to draw 4 little coordinate planes. So like this. You're going to draw 1, 2, 3, 4. Okay? Make them little coordinate planes. And you're going to draw a picture of a line on each. You can use a highlighter or a different color so it stands out. And I want you to draw a picture that has a positive slope, a negative slope, a 0 slope, and an undefined or a no slope. Draw a picture of draw a line that has each of those 4 things. Okay? So I'll pause for just a second while you think about that. So positive slope, negative slope, just make sure you're drawing a picture that you know what the direction of the line is going to go with. I would highlight those lines or at least make them stand out in some way. If you look at Kendall, she just went ahead and made her axis a different color Then her lines, they kind of stand out. She should write the words positive, negative, 0, and are undefined as well. Zero slope. What kind of a line is that? Demetra? Horizontal. Very good. Horizontal line. And then undefined is going to be what kind of a line? Vertical. Very good. So we know what they're going to look like, okay, on the front of the card. On the back of the card, okay, we can also write the formula here. So we'll say that the slope formula is just simply y2 minus y1 over x2 minus x1. What's the IB word for slope? Gradient. Please add that as well. You might want to put that maybe on the front here next to slope. You can put it on the back if you want. I don't really care, as long as you have the word somewhere and you know what that means. Gradient and slope mean the same thing. Okay? So you want to make sure that's taped on the right-hand side. Parallel versus perpendicular. Let's draw a picture of both of those on the front of the note card. On the back of the note card, I want you to talk about, write a sentence for each. Parallel lines have what kind of slopes? Perpendicular lines have what kind of slopes? So let's summarize that for us, okay? So with parallel lines, what you're looking for here is literally parallel, meaning that they never intersect. Perpendicular lines, you know that they're going to intersect in a 90-degree angle. Parallel versus perpendicular. There is some notation that you should add here, because parallel lines, we actually mark them in a certain way to determine it, to show that they're parallel. We actually mark them with a little arrow, like this. Okay? So that means those two lines are parallel. So if you would just add that little, these are supposed to be like little triangles, okay? And then this is the notation for perpendicular. So just make sure that that notation is added there. We have parallel lines, and we have perpendicular lines. And then I want you to write some sentences about how do we determine using slope if the lines are parallel. So you would say something like, parallel lines have what kind of slopes? Same slopes. And perpendicular lines have not just reciprocal, opposite reciprocal. Got to put both of those together. One alone is not enough. Have opposite signs. One's positive, one's negative, and the numerator and denominator are switched. Good. I wasn't recording, but make sure that you are writing equations of lines. Slope-intercept on the front, point-slope on the back. So on the back here, you should be able to tell me what the slope formula is. I just told you what the slope-intercept form is. You need to fill this part in as well. What does M stand for, and what does B stand for? Do you know? M is slope, and B is y-intercept. Good. All right, point-slope form, we know that one as well. We just put it on our note card. So we have two different places where it should be. We'll worry about standard form and all that in a minute. Can we keep going down? Okay. And then down here you should be able to answer. Parallel lines have, perpendicular lines have. Parallel lines have what, Ashley? Same slope. Holy cow, if we don't know this by now, right? The same slope. And let's see. Brian, what do perpendicular lines have? Opposite reciprocal slopes. Good. Excellent. Okay. So what we're going to do here is we're going to work really a lot today with this point-slope form. You can go ahead and put this kind of foldable right back in your binder. It should be in the very front of your coordinate geometry section. And honestly, today we're going to kind of wrap up coordinate geometry. We're almost done with it. After we do equations of lines, we're just going to review on Thursday. You have a test next Monday on all of coordinate geometry. Okay? Slope, midpoint, distance, equations of lines, and constructions. So you have quite a bit of a big test. This is your first test, and it is coming up next Monday. Okay? So keep that in the back of your mind. I know. But let's finish our equations of lines first, okay? So you want to take your notes out if you haven't done so already. You want to title today's notes, Writing Equations of Lines. The dates on the board, so right where, underneath what it says, what are we doing today, you should see the title of the notes and the date of the notes. So anytime you want to come in and go ahead and get started on that, that's exactly what I'm looking forward for you to do, okay? And this is a great time for you to use your graph paper if you have it, because we are going to be doing some graphing. It's kind of up to you. If you don't have it, you can do it on regular paper. That's okay. Go ahead and we're going to do several examples today. So it's kind of a big note day. I don't like to do a ton of notes, but today is kind of one of those days, unfortunately. And let's see what we can do. Get through it. All right, so this is not something that's challenging or difficult. Didn't mean it to be. It's like we're going to start off easy and kind of scaffold and get harder, okay? All I mean here, the slope is 2. We know that this M stands for slope, right? And we know that this B is your y-intercept. And you're literally just going to write the equation. So it's going to be y equals 2x minus 3. And I want us to graph this line, okay? So I want to go ahead and just create a little sketch real quick, and I want us to graph what it looks like. So let me go ahead and find our graph here. And we have to remind ourselves when we are graphing, where do we start? With the 2, the negative 3. The y-intercept, good. And so we know that this is our y-axis. We know this is our x-axis. So we're going to start at the negative 3 on the y. And that is actually a point that's on our line. Bless you. And then how do I use the 2 to get the next point on the line? Tell me, Demetra. Okay, the over, there you go, okay, because I'm like, I don't know what over means, right? So she's right. She went ahead and made our slope a fraction because we know that the numerator tells us how far up or down we go, and the denominator tells us how far left or right we go. And we are going to go, because they're both positive, up 2 and right 1. So up 2, right 1. I can continue this pattern in the same direction, keep going up 2, right 1 to create several points on the line. But honestly, it's really just not even necessary because the line is just right here. Okay? And it is a line, so we should make it a line. Okay? We wrote an equation. We can graph it. You should be able to do both. Now, notice what I'm given in both cases to be able to write the equation. I'm given a slope, and actually, isn't the y-intercept just a point? It's the starting point in this particular equation. So in order to write an equation of a line, that's all you ever need, is a slope and a point. Anytime you're given both a slope and a point, you can do it. So let's try a different situation. Okay? So I have a slope, and I have a point. And I want us to write an equation of the line that goes through this point, but it has this particular slope. Okay? So this is our second example for our notes for today. Now I have 2 different things up here because there's really 2 ways to do it. And maybe you should watch both ways first and decide which way you prefer, and you can do it either way. I will tell you, if you're going on into mathematics with the IB program, you really should do it on the way the left-hand side shows us, because that's the way that your IB teachers are going to teach you. But on the right-hand side, maybe is the way your algebra teacher taught you. Okay? So I'm going to show you both, but really would like us to work on maybe just doing the left-hand side. Okay? So let me show you the way that maybe your old algebra teacher, I call her old, he or she might not have been old, your last year's teacher, right, okay, might have showed you. And it's a perfectly acceptable way to do it. It gives you the right answer. It's just using a formula that we typically don't use, but that's okay. So when I'm using on the right-hand side, I'm looking for, in the equation, I'm looking for a number to replace with the m, and I'm looking for the b. Am I given any of those numbers right now? What am I given? The slope. I'm given 3/4. So I know that I'm going to put a 3/4 in for my slope formula. Now, do I have the b? I don't. Like I had it before. I was given the y-intercept, wasn't I? So I'm not given the b here. So I'm going to have to find the b. But look what I am given. I am given a y and an x, aren't I? So I can replace the y and the x with the x and the y from the point. And that will help us find the slope, or find the y-intercept. So what I mean is the y was going to correspond to 2, and the x is going to correspond to -12. Have you seen this before? You're just trying to find your b? Again, if you haven't seen it, you don't have to worry about it. Okay? What is 3/4 of -12 without a calculator? -9. We don't remember how to multiply them. 3/4 times 12 over 1, not 12, 21, 12 over 1. And you go ahead and you know that 4 goes into 12 3 times. 3 times 3 is 9, 9 over 1, or -9. You've done that before, probably more like in 5th grade, but I know you've done it. So we know this is -9 plus b is equal to 2. To solve for b, I do what? Add 9. So b is going to be 11. So my equation, my final equation that I'm looking for is y equals 3/4 x plus 11. So that is one way to do it. You just got to solve for b, right? Okay. Sometimes if you're not given b, you have to solve for it. No big thing. That's one way. And you may or may not have done that last year, but this is the way I want us to kind of focus on it. Okay? If you look at this particular formula, you are given room to put in your point, and there's room to put in your slope. So you literally aren't solving for anything. You're just plugging in what you have. It's that simple. Okay? So let's plug in what we have. Y minus, notice the x and the y stay. Y minus what? 2. Very good, because that is the y coordinate of my point. Now what? 3/4 is my slope, and I'm going to have x minus, x minus a -12, or x plus 12. Very good. I agree. That is an equation. And if I simply only ask you to write an equation, you may stop here because it is an equation. However, if you read the question in this case, what have I asked you to do? Put the equation in. So how do I take this equation here with all the parentheses and stuff and put it in slope-intercept form? Alex? Distribute the what? Perfect. Let's start there. So I'll go ahead and distribute the 3/4. And then what? So when I distribute the 3, I still have y minus 2 over here. I'll deal with that in a minute. I have 3/4 x plus 9, because you already told me that 3/4 of 12 was 9. And then we're just going to add 2. Notice what happens. You get the same exact answer you got if you did it the other way. Right? Taylor, you going to be all right? You just face planted into your notebook. I'm kind of scared. Are you all right? You like algebra again, Miss Macker? Really? Oh, that's just geometry. Well, it's only for a day, and then we move on. Wait till we get to logic. Then I'm really going to blow your mind. It's going to be like really like out there. I can't wait. It's fun. But I agree, algebra, I'm not a fan either. That's okay. Same thing, okay, either way. All right. Let's take it up a little step further here, okay? And this will be the place where we stop for today, okay? Our last example. Place where we stop. This one's a little bit different. Why is this one different? Gives me 2 points, but no slope. So what did I tell you that you always need to write an equation? You need a point and a slope. So in this case, I'm going to have to do some work to find what first? The slope. You got to find the slope first. So that's going to be the key. I've always had to find the point. Always have to have one of each, either the point or the slope. So let's find the slope first. And that's the formula that we already know. Good. The y2 minus the y1. So I'm just going to write the formula again. You don't have to write it again if you know it, because we should probably know it by now. And let's plug in what we know. All right, Miss Faceplant, help me out. Tell me what I write.
9 plus 6.
Good. 9 subtract a negative makes it plus. Perfect. So she started with the first point and went in this direction. I don't care as long as you're consistently doing that. And then over here we have, we'll go ahead and simplify, and I get 15 over 1. That's a pretty steep slope, 15. You usually don't work with slopes that steep, but it's okay. Just real steep line. Close to vertical almost. Close, not that bad. All right, here we go. So now what? I've got a slope. What point do I use? Which one? Asia, which point do I use? Can you use 6, 9? What if I wanted to use 5, negative 6? What if I was like, I don't like your point. I want to use my point. I could use either one. Perfect. Okay, it doesn't really matter. But she wants to use 6, 9. And honestly, why might that be the better choice in this case? Because the other point has a what in it? I mean, either one will give you the right answer. You just have to be cautious. That's all. All right? So let's use Asia's point. She fought for her right. Right? So here we go. So we're going to use the what? We're going to use this formula. This is the one that I like to use. Okay? We have a point. We have Asia's point, and we have our slope. And it's okay to just say 15 at this point. You don't have to put it over 1. Okay? So let's plug it in. So we have y minus 9 equals 15 times x minus 6. Now, am I done? If it just said write an equation, would I be done? Yes, because it is an equation. But because it asked you to write it in slope-intercept form, we have a little bit of work to do. So what do I need to do here? Distribute the 15 and add the 9. Good. So I'm going to say 15x minus, ooh. What? 90. Good. And then we'll add the 9. We got some big numbers here. Negative what, sweetie? 81. And that is the equation I'm looking for. Go ahead with your bad self. There it is. All right. Perfect. If you would for me, we have about 15, 20 minutes left. Take out that slope packet that we were looking at last class, where we went and measured slopes around the building and that kind of thing. Would you hand me it? What's right back there in the corner? Nope, 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 nope. That one. There you go. That's all right. And go ahead and open it for me. These problems are a little bit different If you look at these, it says 3-8 practice. Do you see that? Okay. It says write an equation of the line parallel to. Hang on a minute. Write an equation. So if you look at problem number 3, for example, how can I combine what I know about writing equations of lines with what's parallel and perpendicular? I'm looking at question number 3 on the 3-8 practice. I have to write an equation, right? So if I have to write an equation, what information do I need? I need a point and I need a slope. What do I have? Do I have a point and a slope in number 3? Well, I definitely have a point. Would you agree? It says I want to write an equation of a line parallel. So I want it to be parallel to this line that's given to us, which means what slope do I want it to have? Since it's parallel, it better be the exact same slope, right? So I want this point and I want this slope. Could you write the equation that goes with those two things? That's what I'm looking for. Let's try it. Go ahead and write it right on there. Find the equation of the line that's parallel. So remember, we're using this equation to write the equation of a line that's parallel to number 3. Harriet, do you not have that? So we got to remember what we're plugging in. Remember, the x and the y stay, and I'm just plugging in my point and the slope that I want. Now, since it's parallel, I want it to be the same slope. You're going to be working on some questions that I want to be perpendicular. So the slope would have to be opposite reciprocal. So make sure you're paying attention to what the directions are saying. Okay? Does it tell me what form I want the equation in? Does it say write the equation in slope-intercept form, or does it just say write an equation? Write an equation. So I can actually stop once I've plugged my points in, can't I? Kind of nice. It's okay to go ahead and put it in slope-intercept form. It won't be wrong.
Do you do anything with 12 words?
No, the 12 just happens to be there. All right, so let's plug in what we got. Hopefully this is the answer you got. So y minus 1 equals negative 5 parentheses x plus 2. Done. Done. It didn't say put it in slope-intercept form, did it? It just said write an equation. I wrote one. Now, you have to be careful because sometimes the directions say put it in slope-intercept form, right? Okay. So I'm going to give you the rest of class, which is 10 minutes to finish. This is homework. Okay, both pages here, 1 through 20. Okay, so it's quite a bit. Not all of them take as long as others, okay? And so this will be due next class. No, next Thursday during class, first block.
I don't have